Not story. Group. Okay. Okay. So how are we doing? What are we doing? What are we doing? We are going to be working on the abacus. That's what we're doing. I need to get my sound effects. All right. How are we doing? Yeah. What are we doing? We're talking about the abacus. We are going to be talking about the abacus, and this is the abacus. Okay. So what we're going to do is pin this. Pinned. Okay, so here's my abacus, and what we're going to do is we are going to read the abacus. Here is my abacus, and what we're doing is we're going to know that we have the top beat. These are the top beats, So here's a horizontal bar, and then we have the bottom beats. If you look, these are the bottom beats. This is the beam. This beam is the horizontal bar. This is the horizontal bar, right? Make sense? So this horizontal bar is what tracks our information. This is what tracks our beats. So when we look, we have our bottom beats, right? These are the bottom beats. These are the top beats, and this is the frame. Because this is the frame, right? So when I do this, this is what we call zero. What are we doing? We are going to be counting on the abacus. So one of the things to understand how to count on the abacus is this. Zero. Zero is easy because none of the beads are touching this horizontal bar. Because none of the beads are touching the horizontal bar, this is what we call zero. So then what's after zero is obviously one. Okay, so what does one look like? One looks like this. One. That's all it is. One, 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 one. So these are all one. And then when we look, this is two. We have two snakes. Wah! I'm trying to. Okay, what are we doing? We're doing two snakes. So two looks like this. One, two. So if I look at my abacus, I can do two, 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 two. And then we have three. After three, what is three? Three is three chipmunks. So when we look, we have three, 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 three. What are we doing? We are reading the abacus. And what we're trying to do is we're trying to understand what it looks like. So these are koalas. I think I was trying to do like big koalas, right? So 4, 4, 4, 4, 4, 4, 4. But if you had all of them, they're like actually 8. But that was my bad. All right. So we did the 4, and then what are we doing? Okay, we know that we have some activities, and after the activities, these are just about bead recognition, and this one is preschool. This is my preschool workbook. And when we look, this is horses. I have horses. I never learned this on calculator. Oh, that's interesting. So we have horses. 1, 2, 3, 4, 5. We have 5 horses. Now, interesting thing about the abacus is the top beat will always be the value of 5. The top beat is always the value of 5. So when we do it, we always bring that down. That's it. So if I show you what all 5 looks like, this is what 5 looks like. So 5, 5, 5, 5, 5, 5, 5. These are all 5s. Why? Because they're touching the horizontal bar. Because the beads are touching the horizontal bar, this is what we consider 5. So then we know after 5 is we have 6. We have 6 sheep. 1, 2, 3, 4, 5, 6. So we have 6 sheep. So when we look, we do 5 and we do 6. 5 is not, this is not 6, right? This is 1 and 5. When we do 6, it's like this. 6, 6, 6. Whoa. 6, 6, 6. These are all 6s. Does that make sense? So when we look, every column actually has a place value. But right now, what we're doing is we're understanding how to read the abacus. And then we have 7 crocodiles. 7 just looks like this. 7, 7, 7, 7, 7, 7, 7. And then we have 8. 8 is 8 bunnies. There's 8 bunnies. 1, 2, 3, 4, 5, 6, 7, 8. So we have 5, 6, 7, 8. Make sense? This is 8. 5 and 3 is 8. That's 8. 3 and 5 is 8. And then 8, 8, 8, 8. And what's 9? We have 9 cows. Okay, 9. Just we add this. The whole column itself is 9. 9, 9, 9, 9, 9, 9, 9. These are all 9s. Anybody have any questions? So what we're doing is we're learning how to read the abacus. Okay, that's good. That's great. That's easy, right? Simple to use, easy to understand. So what's going to happen next? Well, what's 10? How do you do 10 after this? Well, 10 actually needs to look like this. First thing we need to do is understand this is 1, right? So if I have my ones, I'm sorry, this is 9. So if I have my ones placed, because I have my ones placed, every column is a place value. Every place value has a digit. So 9, 10. I'm sorry, ones, tens, hundreds, thousands, 10,000. So when I look, this is 9, right? All of this is 999,999, right? That's what this is. 999,999.99. That's what this is looking at. But I don't want that. What I want is 10. How do we do 10? 10, if this is 9, what does 10 look like? 10 looks very familiar, right? 10 is 1 and a 0. So there's a 0 in the ones column. I'm going to make 0 in the ones column. And then what happened? I have 1 in the 10, or no, 1 in the tens column. We have 10. That's what we have. Thank you so much for the hearts. Oh, thank you, Eli, for the rose. Does that make sense? So what we're doing is we're understanding how to read the abacus. Because we know how to read the abacus, we will go into adding, subtracting, multiplication, division. But the first thing we need to do is understand how to read the abacus. When we understand how to read the abacus, and then we can move forward. But here is 10, 0, 1. If I did hundreds, right, this would be 200, 210. And then what do we have? We have 3,000. This would be 3,210. 3,210. Make sense? And thank you so much for the likes. So we have, what did we have? We have 4,000. No, 43,000. 43,210. Point 51. That's what it looks like. Make sense? Anybody have any questions? Questions? Put in the 1 for make sense. Put 2, let's do a review. 1 for yes, 2 for review. Let's do that. 1. Okay, great, Desi. Thank you so much. Thank you so much. Okay, so we're going to continue on. Now, the first thing we're going to do is, thank you, Ashley. So what we're going to do is understand, we're going to learn how to move the beads now, right? What's going to happen is we're going to understand how to learn beads. What we want to do is notice I don't have big pudgy fingers, but if you did, you should still be able to utilize the abacus. We want to be gentle. What we want to do is we want to be gentle. And notice that we're going to use the edge of the beads. When we use the edge of the beads, right, we can move them. So when we look, we do 1, 2, 3, 4, and then we have 5. 5, 6, 7, 8, 9, right? So what we're going to do, we're going to be gentle. We're not going to be doing this. Why? Because we don't want to be aggressive when we do math. So, okay, so that's the other thing. And then another thing is when I have my answer, right, and I do this, make sure you do not flick too hard. So don't be like Zeus and flick too hard, because what happens is your answers becomes all wrong. All right. So that's the one. And then what are we going to do? Oh, yeah. Okay. So that's about moving. So now what we're going to do is we're going to start understanding how to move the beads. So what does that mean? Well, in abacus world, what we do is we understand that we're going to be looking at the added. We're not going to be looking at the result. So in mainstream school, I don't know why we focus on the added, but in mainstream school, I don't know why in mainstream school we focus on the result, but in abacus world we focus on the added. What does that mean? We want to make sure we understand what we're adding, right? And the question is do we have enough? Right. So now we're going to start bringing in critical thinking. We have 5. My question starts with 5. I'm going to add 5 to the abacus. When you see it, I'm going to go to the horizontal bar. I'm going to add the 5. So now the 5 is being counted. My question is, my add-in that I'm trying to do is, my add-in is 1. So my question is to you, do we have enough? Can we add the 1? Yes, we can, because we have these beads to add. So we can add the 1 bead. So what are we doing? What we're doing is we're learning and changing our mind a little bit. We're doing a mind shift to look at the add-in and not the result. So again, here's my question. My question is 7. So if I have 7 on my abacus, my question is can I add the 1? Can we do it? Yes, we can. So we're going to add the 1. So it's the same thing with all the other numbers. So here is, we already did we do 7? We didn't do 7. If we did 7, right? We did 7, and then my add-in is 1. So I'm going to add my 1. My answer is 8. And then we do it again for 2, right? So the here is 5. We do 5 again. That's 5. And then my add-in is 2. So I'm going to add the 2 beats. My question is 5 plus 2. my final answer is 7, right? So when we look, we can do it again. So if I have 6, 6, and notice what I'm trying to show is the beads that we're moving. We're moving these 2 beads. Can I do it? Yes, we can. So we're going to add these 2 beads and we're going to move it up. So what we're doing is we're understanding how to move the beads. So my final answer is 8. We have 3. 3. There we go. 3. So 3 is the same way. We have 5, 6, 7, 8. 3. I'm sorry, 5 plus 3. And then we're just going to move these beads. It doesn't matter which beads we're moving. It just matters the amount of beads. So when I do 6 plus 3, these are the only numbers I have. These are the 3. We're going to be big people and we're going to move the whole thing, right? You could count it 1, 2, 3, or you could be a big person, just do 3. All right, so we have 4. 4 doesn't have a lot of numbers, right? 4 is just either 4 plus the 4 or minus the 4, plus the 4 minus the 4. That's all we're doing, right? So there's only 4 beads at the bottom. You're going to move the whole thing. So again, what we're going to do is understand that when we add means we're going to the horizontal bar. When we go subtracting, we go away from the horizontal bar. So here is 2. When I subtract 1, can we do it? Yes, we can. So we're going to minus the 1. So my final answer is 1. These are so easy, Lynette. What's the point? The point of understanding this is the fundamentals, right? What we're trying to do is I'm trying to lay down the groundwork. What I'm hoping you guys will do. Hello, Pax. Welcome back. Welcome back, Pax. Okay, so what we're going to do is we're going to understand that we're going to take away. When we take away, we're minusing, right? We go away from the horizontal bar. So when we look, that was 1. And again, we're looking at the add in or the subtract head, right? So if I have 3, I have 3 on my abacus. I want to take away. Thank you, Pax. When we want to take away the 2, it's minus away. We want to take away the 2, right? These are the 2 beads I want to take away. So if you look, I have 3, I want to take away 2. If I have 4, I want to take away 2. It doesn't matter which beads, it just matters there's 2 that I'm taking away. So again, taking away is away from the horizontal bar. All right, so that's 2. 3 is the same, right? 3, if I have 4, I have 4 and I take away the 3, I'm taking away the 3. Yeah? Okay, 4, easy, right? Because it's either 9 take away 4, which gives me 5, or it's 4 take away 4, which gives me 0. All right, 5. 5 is the same. So when we look, we want to add it to the horizontal bar. When we subtract, we're going away from the horizontal bar. So if my question starts with 3, I'm going to add to the horizontal bar. My final answer is 8. Again, we're looking at the add-in. We're not looking at the result, right? So as we go through, we are looking at the add-in. So if I have 4 and I want to add the 5, can I add the 5? Yes, we can. So we can add the 5. There we go. So now what are we doing? We're going to do 6 and we're going to go through all the numbers. There's only 9 numbers that we have to worry about. So when we look at it, we have 1 and then plus 6. 6 is 1 bead on top and 1 bead on bottom. When we want to subtract the 6, it's minus the 5 minus the 1. So what we are doing is we're understanding how to decompose as well as moving the beads. So when we do 7, it's plus the 7, plus 5, plus 6, plus 7. I bring it together. When I subtract, it's minus 7, minus the 5, minus 1, minus 2. And I move it away like this. So my final answer is 1. Does that make sense? Let me know in the comments 1 if that makes sense. And we can do it again with 8. 5, 6, 7, 8, we bring it together and then we take it apart. When we take it apart, right, we want to subtract the 8, it's take it away, right? We're moving it away from the horizontal bar. We're going to use 2 fingers to remove the beads from the horizontal bar. All right, so that is 8. After 8 is 9. 9 is easy. Why? Because it's the whole gambit. Okay, so that's what we're doing is we're understanding how to move the beads. We're done. I am beyond confused, but I just came in. Thank you, Arlene. Arlene, thank you so much for the finger of heart. I don't know what to say to that. Beyond confused. I'm not sure how to unconfuse you. If this is 1, this is 2, This is 3. This is 4. So now when we look, all the beads are touching the horizontal bar. This is what's being counted. Because this is being counted when I move it away from the horizontal bar, now it's not being counted. Does that make sense? Baby. When we look, the horizontal bar, this is my horizontal bar. This horizontal bar is what keeps track of our beads. That's what it is. These are beads. These are the bottom beads. These are the top beads. The top bead always has a value of 5, no matter what. No matter what. So if I do this, this is all 5. 5, 5, 5, 5, 5, 5, 5. These are all 5s. So don't flick too hard, because if you do, then your answers will become wrong. My son doesn't want to use a calculator. I've seen an abacus before, but never learned how to use it. He doesn't want to use a calculator. That's good. How old is your son, Arlene? It depends on how old the child is, right? If your child is 5, he should not be using a calculator. If your child is, I think, 12 or 13, then that's when they're allowed to use calculator. Um, Yeah. So what's going to happen is, okay, so we've done 5. Well, after 5, we have 6. Because there's 6, 5, 6. I understand now. Everything above. Yes, thank you. See, you can't be beyond confused. That doesn't make sense to me. So we have 5, we have 6. So together, we make 6, right? 1 and 5. We do 2 and 5, we make 7. 3 and 5, we make 8, right? This is now decomposing like a kindergarten skill. We can decompose because what? Abacus makes it into manageable chunks. So if we do 5 and then 3, we have 8. And then 4, we have 4. This is 4. And then we add the 5. Now we have 9. Make sense? So, Arlene, if you don't mind me asking, how old is your son? And did you want to use this for your son? Because you can use it. This is what tracks your numbers, right? So all we're doing here is we're tracking numbers. Some kids have a really good sense of number skills. It's good if they use it. It's good if they don't use it. It's up to you. Do I force it? I enforce it because I believe it's the greatest thing next to sliced bread. And also, it helps when you get to the bigger numbers. But right now, it's super easy, right? The numbers are super easy, right? I know how to do all of this. That doesn't make sense. Why are we doing this? Well, we're doing this so we can see how the beads move. Does that make sense? So going through, we got to go through a little bit of understanding before we can go into the bigger numbers. All right. How are we doing? Um, okay. What's after this? We're going to start going into how to read the abacus again. So what we're going to do is we're going to read the abacus. What does that mean? Well, I made this thing. This thing is a book. This book is a maze. Uh, with the pictures, since they are color coded, does it differ? No, it doesn't. Because I can't say move the blue bead, move the brown bead. So it all matters about positioning. Make sense? So when we look, it's all about the positioning. I just use this one because it's nice and pretty and it's colorful and it's nice to look at, right? But you can use this one. This one is just works as just as the same. The only thing that's different on this one is that it's 13 columns and this one is 7 columns. Because size matters. Why? Because it depends on how big your numbers will get. So when we look, it's all about the positioning. Again, it's the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10. Whoa, 10. Yes, you can multiply and divide on the abacus. A-W-I. Thank you so much, Pax. Okay, the book. We got to do the book. That's the maze book. So here's the maze book. This is the maze book. What we're doing is we're going to understand how to read the abacus some more. So what we're doing is I'm going through the process of the first thing we need to do is understand how to read the abacus. We move the abacus beads, and now we're going back to understanding how to read the abacus. So here is a 2-digit puzzle maze. And what I did was I made it into a little bit more interactive. And what we're going to do is we're going to start looking at our numbers. So if I show you this number, this one right here, what number do we think that is? So if I have that number on the tens, right, this is my tens, and then I have this number on my ones. What number do we think this is? Put it in the chat, please. Comment below with it. Oh, I wonder. How are we doing? What number do we think that is? Can you divide with this? Yes, I can divide with this. Can I show you? Not right now. Because I want to know, can you read this? If you don't know how to read this, then there's no point of dividing or multiplying. Because I could do this and you won't know. 91. Thank you. Thank you. 91. Thank you, everybody, for joining. Thank you, everybody, for commenting. So if I have this number, so going from this number to this number, right? It's, oh, that looks very similar. What number is that? I wonder. Oh, that's the shopping cart. That's a subscribe. I got to figure out how to put in my services. All right, cool. 92. Yeah, thank you. Thank you. A TikTok. Yes. So 92, and then we're over here. So it doesn't seem like that baby and letter J understands. Thank you, guys. Because we need to understand how to read the abacus before we can start doing anything dividing or anything subtracting or even multiplication or division. But yes, it is possible to do it. So we have our tens and then we have our ones. This is my tens and then this is my ones. What number? Thank you, a TikTok. Yes, thank you, a talk. A talk. There we go. A talk. Thank you, Arlene. Yes, and Joshua. Okay, so we have 15. So we're over here. And then we have that number. So if we have that number, again, we have our tens, right? We have our tens, and then we have our ones. Oh, I think they left. Cool. We're all right? No worries. I'm okay. How are we doing? 52. Thank you. 52. So what we're doing is we're just going through going through the maze, right? So now we're over here. Because we're over here, we can do that. So we have this number, 70, right? 70. 5, 6, 7. And then we have, what number is that? 5, 6, 7, 8. Okay. I think if people have left. 78. Okay, cool. So, ATOC, since you're the only one in the room, do you want to go further in or do we want to continue with the maze? It's up to you. We can continue with the maze or we can start going into adding and subtracting. I don't know if it's Arlene. Arlene, are you still here? Because you guys are commenting. I don't know if Eli is still here or Pax. I don't know if Pax is still here. If you guys are still here, let me know. We're done with the maze. We can move on. Because I don't need to stay on the maze. I mean, I know how to read it. But if you like the maze, we could do the maze. I'm still here. Okay, good. Do we want to continue with the maze or do you want to learn how to add and subtract? Further, Okay, let's do it. Adding, subtraction. Yeah. Arlene, you ready to subtract? Because you guys are the only ones here. I will accommodate. Adding and subtract. Okay, good. So we remember when I was talking about if we had enough beads, right? Because I know you guys were here for that, right? My question is do I have enough beads to add the two? Yes, I do have enough beads to add the two, right? So I'm just going to add the two. So the question is what happens when there's not enough? What do you mean not enough? Well, yeah, right? If there's not enough beads to add enough, what are we doing? We're teaching, well, okay, do you know, I this is a I don't it's not a rhetorical question, like I truly want to understand, do you guys understand or why do we teach the kids how to add the five? How do we make a five? Why do we want to make a five? That's my question to you. Like, why are we teaching them this? Like, I know why I teach it in abacus world, but I don't know why we're teaching it in mainstream. What do you think, why we teach them? Somebody said it's because it's easier, the half of 10, and we have five fingers and five toes, so it kind of makes sense. But this is a thing, right? And what we're going to do is we're going to power up this information, this concept. We're going to power it up. What does that mean? Well, if you notice, here's my question. Um, my question is, let's do this one. 2 plus 4. That's really easy. I know it's easy, but I want to show you the fundamentals, right? So I want to do the 2. When I add the 2, my question is can I add the 4? Repeat pattern. I guess so. I guess so. Eh, Okay. But there's no repeating pattern of making a 5, though. You know what I mean? Okay, anyways. So we want to add the 4. Notice I want to add the 4. When I add the 4, there's not enough beads. I only have 2 beads to add. But we know this concept, right? We know that when we want to add the 4, what do? We have to plus the 5. Let me find mine. What are we doing? We're taking this concept and we're modifying it, right? We're taking this concept, right? We take this concept. So what are we doing? Well, we're going to isolate this variable. Why are we going to isolate the 4? We're going to isolate the 4 because the question is the add-in. Remember, when in abacus world, we focus on the add-in. Yes, ATOC, yes. Yes. So we're going to do 4, right? So 4 is equal to 5 minus 1. Yes, exactly. So what does that mean? Well, if you look on the abacus, we have 2. And then what we're going to do is we're going to utilize this 5. So we're going to add the 5, take away the 1. So my final answer is 6. Atok, you've been here before, yeah? Or is this your first time? Arlene, is this your first time? Because if it is, we can continue on. If it's not, we can go further into more complex. Oh, good. Oh, okay. So what we're trying to do is what we're doing is we're not memorizing multiple. We're not memorizing doubles. What we're trying to do is we're trying to understand a concept and memorize the concept, right? So before 2 plus 2 plus 2, whatever, right? We're not doing that. What we're going to do is we're going to understand how to make a 4. So when we look, right, we can do it again. We can we can do this again. It becomes more versatile. So we have 3. We have 3 on the abacus. When I add the 4, there's not enough beads. Look, I have enough to plus the 5 minus the 1. Just as ATOC said, I'm going to plus the 5 minus the 1. So my final answer is 7. Does that make sense? We can do it again with this 4 plus 4. Again, we're not going to memorize what 4 plus 4 is, right? You can do number lines. You could, right? You could do little boxes and circles. You could memorize this concept, right? If I want to add the 4, there's not enough beads to add the 4. What do I want to do? Right? I want to plus the 5 minus the 1. So I'm going to plus the 5, take away the 1. So my final answer is, can you put in the chat what my final answer is? Does that make sense? Let me do it again. That was too confusing. That's okay. So what's my answer? 8. Thank you, ATOC. So when I look, here's the same example, right? My same example. This is 4. I have 4 on my abacus, right? If I have 4 on my abacus and I only have a nickel, but it's only worth 4 cents, I'm going to give you my nickel, but it's too much. So what am I going to do? I'm going to give you my nickel, but you have to give me change, which is 1 penny. So what does that mean? That just means that I just took away the 1 penny. This is mine now. So we're going to give you the nickel, and you're going to give me the 1 bead. So what your answer becomes 8. Does that make sense now? Why are we doing it? Because we are substituting. We're doing a little bit more algebraic terms, right? We're substituting. If I have 4 on the abacus and I want to add another 4, I'm going to substitute plus the 5 minus the 1. Thank you, AI TikTok God, for sharing my life. I see you. Okay, so ATOC and Arlene, does that make sense? Yeah? So what did we just do? We substituted 4. We had 4, right? And 5 was too much. Okay, good. Arlene, did that make sense? So what are we doing? What we're doing is we're utilizing the 5. Okay, good. So we can do it again. When we do it again, let's do 3. 3 has the same concept. Again, we're not going to memorize the 3. We're not going to do 3 times 3, right? What we're going to do is we're going to do 3. There's not enough beads to add another 3. To add another 3, it's taking a while to process. It takes a while to process because it's a different way of thinking. And I appreciate that you're opening your mind. Hold on with that one, ATOC. We're gonna get to that. Let me add that into my notes. But for right now, I'll add it into my notes, but keep that in mind. We're gonna pin it. We're gonna pin 8 plus 4. Okay? Let's pin it. So let's continue on with the 3, right? Why? Because it's still handling how to make a 5. We're still in the process of making a 5, but now we're doing different ones. Does eat hey, letter J does no, it doesn't. If I did this, I would like to tell you to move the brown bead. It doesn't matter. It's all about positioning. So we do 5, we do 1. 1, 2, 3, 4, and then 5. This is 5. The top bead touches the horizontal bar. Now we have 5. And then we have 6, 7, 8, 9. Because we have 9, right? They're touching the horizontal bar. Does that make sense? So none of the colors mean anything. It's all about positioning. It's all about the columns, right? So what's going to happen is when I have my columns, I have my ones, my tens, my hundreds, my thousands, and my 10,000. Does each? Okay. Okay, so we're back to here. So I had 3. When I have 3 on my abacus, I'm going to add 3. To modify, right, we're going to modify. We're going to do modification. We're going to understand that we're going to use this 5. Right? We're going to understand how to use the 5. When we add the 5, that's too much. When we add the 5, it's too much. I need to minus the 2. So I need to take away the 2. So my final answer is 6. So Y represents subtraction with the red bead. I've always wanted to know how to. Oh, hey, Ash. Welcome. Okay, let's continue on. We have 4. When we have 4, right, I want to minus the 5. Don't forget what we're going to do. Plus the 3. I'm going to plus the 3. When I plus the 3, I'm going to power it up. To plus the 3 is what? Plus the 5. I'm going to add the 5 and I'm going to take away the 2. Thank you for the hat. So when I colors are just for fun. Yeah, colors are just for fun. So when we have 7, so my final answer is 7. Does that make sense? Ash, when we read the abacus, we have 1, or this is 2, right? This is 2, this is 3, this is 4. And then after 4, we have 5. All the top beat is a value of 5. We have 5, we have 6, 7, 8, 9. Are we all right? How are we doing? So when we look, right, what we just did is we powered up our, let's do it again. So if I have 4. 1, 2, 3, 4. I have 4. I have 4 pennies. 4 pennies. 1 cent each, right? 1 cent each. But I'm going to give you 3. The problem is I only have a nickel. I only have 5 cents. So what are we doing? We're now trying to think about how do we utilize what we have. If I give you a nickel, it's too much, right? So what I'm going to do is I'm going to remove 2 pennies. So when we look, we have the 5 and we remove the 2 pennies. I don't know what Ash just asked. Okay, so my final answer is 7. 5, 6, 7. Does that make sense? So what I'm doing is I'm trying to show when we look at this concept, right? We're going to power it up, right? We are going to do some modify. Oh, thank you, ATOC. No, thank you. I appreciate your, participating. Good evening, Ethan. Ha ha ha. All right. So what we're doing is we're understanding how to add the 5. What are we going to do? We can do it again. We can do the same concept again with the 2. What? With the 2, same thing. But now what we're going to do is we're going to do 4, and then if I give you 2, right? You want 2, but I only have a nickel. What's going to happen? I'm going to take away 3. So if I give you my nickel, right? I'm going to take away the 3. So my final answer is 6. 11 p.m. So you're going to be close to midnight math pretty soon. Okay. Yeah, makes sense. Can you explain, Gunroy, the colored numbers? Can you explain colors, number, values? Hey, Spicy Mom, welcome back. Let's do that one instead. So, I am on again. I'm here to spread the good word, please. So I'm going to start here at the ones. The ones is my dot indicator. That's why I start in the middle. So my ones, my tens, my hundreds, my thousands, and my 10,000. Is math supposed to be easier with this? Yes, Ash. Math is easier with this. Thank you, Ethan. Yes, math is easier with this because we can scale it. So, yes, thank you, Lade. Ooh, good, Jay. Yes, the beads only are for making it look pretty, right? Like a model. So we have our ones. When we do it, 1, 2, 3, 4. The top bead will always be 5, no matter what. So if I move the brown bead, this is 6. If I move another brown bead, it's 7. And then 8, and then 9. When we have 9, what's after 9? We have 10. 10 is a 0 and a 1. 0, I'm sorry, 0, 1, 1, 0. That's how we do 10. And now we can count by 20s. I'm sorry, we can count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. Oh, right. Spicy Mom. If you're Neuro Spicy, if you're still here, we didn't do adding and subtracting yesterday, did we? Is it counting from left to right or vice versa? Well, here's a question. If you're counting from left to right, is that how you write? In just regular, when you regularly write, right? When you regularly write, I say 438. Or do you say 830, 400? Fell asleep during multiplication. Right? Does that make sense? No, it doesn't make sense when I say 830, 400. So when I'm looking at it, it's 438. And this is not backwards because my numbers are correct. It's not mirrored, right? I mean, it's a good question. It's a very good question because you know why? Because mainstream math, when we look at it, we go right to left. But we don't, right? We don't do left to right. We do right to left. Even when we do multiplication and division, when we do adding and subtracting, we go from left to right. You could do it right to left, but I feel like it's backwards. So, anyways, but no, that's a very good question. Okay, I'm going back to here. I'm going back to here. We add, yes, we do add from left to right, which is, it's fine if you do. That's fine. Yes, no, that's why Jade was a very good question because what we do in mainstream math is we go from right to left. But in abacus world we go from left to right, just as we read it, right? When we want to add when you add 4,368, we add 734 300, right? But then when we write it out in mainstream math, we go the other way. Yes, we call the numbers from. Yeah, but yes, exactly. Okay, good. So we understand how to do this. Do we understand neurospicy? Do we understand this, or do I need a review? We can review. It's up to you. I just want to keep you up. It all depends on the person. And that's what it is. Math is all about different things. It all depends. Okay, so what we're gonna do is we're gonna understand. We're gonna understand this concept. There's this concept that we're teaching in mainstream math is how to make a 5. Hey, Pax. Yeah, okay, good. You're still here. So 4 plus 1 is equal to 5. This is a concept we're going to do, right? What do you mean we're going to do it? We're going to power it up. So add from, okay. So what we're going to do is we're going to do something simple. Why are we doing something simple? Because if I give you big numbers, it's going to be overwhelming. I want to do something super simple, super simple. Oh no, that's not the one. Super simple, right? We're going to do 4 plus 4. What? That's too easy. I know. Please, 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 please. Okay, 4. On the abacus, I want to add 4. When I add 4 on the abacus, right? When I add 4 on the abacus, I want to add another 4. Remember in the beginning, I said we needed to work on our add-in. We need to figure out, can I add a 4? Can I do it? No. No, I can't. So what do? I have this concept. 4 plus 1 is equal to 5. Because I have 4 plus 1 is equal to 5, I'm going to So because I'm going to modify this, I'm going to isolate the variable. When I isolate the variable, I'm going to do 4 is equal to 5. But that's too much. That's too much. It's not balanced anymore. Thank you so much for sharing the live. Okay, so Dolce! My show is on. I'm trying to be more scheduled. All right. So here, plus the 4 is equal to plus the 5 minus the 1. That's what we're doing. Why? Why? Because we want to substitute, right? So here I have this thing where I have 4 plus 4. That's what I have, 4 plus 4. 4, there's not enough. So we're going to substitute. We're going to substitute plus the 5 minus the 1. We're going to plus the 5, take away the 1. And my final answer is, please put it in the chat what number you think that is. What number is this? Yes, thank you, Ethan. Thank you, Nero. Yeah, makes sense? So this is 8. What did we just do? What we did was we understood this concept and then we modified it, right? We powered it up. We can do it. Now it's more versatile, right? Because now we can do this one. Instead of memorizing our doubles, what? 4 plus 4 and then take away the 1. Instead of doing our doubles, what we're going to do is we're going to focus on our add-in. So if I have 3 and I want to add the 4, to add the 4, what am I going to do? I'm going to plus the 5, take away the 1. I'm going to plus the 5, take away the 1. Oh, I got to get an Oh, okay. Kimber, thank you. So here's how we read it. Plus the 5 minus the 1. My final answer is 7. 5, 6, 7. Right? So if I look, this is 1, 2, 3, 4. And then we have 5, 6, 7, 8, 9. I'm still confused on why I have 2 plus 4. Okay, so Jay, when we look, it is better. Maybe it's better if I did this, right? So remember we had the 4 pennies? These are pennies. These are worth 1 cent. 1, 2, 3, 4, 1 cent. I appreciate your comment and I'm going to try to do this. I hope this makes sense. This makes sense, right? 4, right? Does that make sense? Just no. So I'm going to add another 4. Ooh, when I have 4, 4, I want to add 2, right? But the problem is, what's the problem? I only have a nickel. I only have 5 cents. I only have 5 cents. If I only have 5 cents, what am I going to do? I need to give you my 5 cents, but you got to give me back some change, right? So if I give you 5 cents, I need change back because I want to add the 2. Because the question is what? 4 plus 2. I have 4. 1, 2, 3, 4. I have 4. But I want to give you 2. I only have a nickel. Because I only have a nickel, I'm going to add the 5. But that's too much. That's too much. You got to give me change back. So you got to give me 3 cents. 1, 2, 3. You got to give me 3 back. So your final answer is 6. Why not use the numbers below the 5s to add the 6? Because 3 and 3 is 33. Does that make sense? This number to me is 33. When we look, remember, I need to find my little, here, right? 33. That's the tens and that's the ones. So when we look, we can't use this as place value. This is not, this is what we're talking about, place values. Every column is a place value. Does that make sense, Jay? That's a very good question. Does that make sense, Jay? Let me know. Let me know. So if I put this back, 3 is 30. I'm sorry, 33. 33. Yeah. When you when do you think we'll cover multiplication? It depends on how quickly the class can move up, and it depends on how tired I am, how energized I am. Okay, Jay, does that make sense? Letters J. All right. Okay. Uh, Nero and Arlene. Are we okay? How are we doing? So that is adding the 5. And we could do it again, right? We could do it again. We add the 4 and then we add the 5, right? I'm sorry, the 3. We did the 4. Now we can do the same thing with the 3. The 3 can be another power up. So when we do it, we have 4 on the abacus. When we have 4 on the abacus, like here, we have 4 on the abacus right here, just above my head. And then we want to add the 3. We want to add the 3. When we add the 3, we want to plus the 5, take away the 2. And my final answer is 7. Is this how people use the abacus universally? Yes, Kimber. This is how people use the abacus universally. This is not my own system. I am bringing in mainstream math terminologies to the abacus world. So then mainstream math can use abacus, such as isolating the variable. Abacus world, we don't say isolate the variable. We don't say substitute. We just say do it. do it. Do it. Do it. So when we're doing it, you always factor it with the 5. If you need it, you do. Yes. So there is a process that we do. No, 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 no. I understand your question, Kimber, because there's a lot of people that say, "Do it my way. This is the greatest way." No, no, no. This is what we're all. This is. I've been teaching abacus for 20 plus years. Hey, Maud, welcome back. I've been teaching abacus for 20 years, and so right now my process is I'm trying to bring it into mainstream math. So that's why we start talking about making a 5 in abacus world. This is called friends, little friends or big friends and family, whatever, right? We have our own separate terminology. But what I'm trying to do is I'm trying to relate it to mainstream math because I do believe this is the greatest thing next to sliced bread. We have all these other math manipulatives, but nobody knows how to use the abacus. And so what I'm trying to do is I'm trying to educate the world how to do it. So we do a lot of distributive property. We do a lot of commutative property, right? And but we don't say this in abacus world. I'm passionate. I'm not yelling at you. I'm very passionate to trying to figure out how to bridge the gap between abacus world and mainstream because I think it's the greatest thing next to sliced bread. Thank you for the follow, Kimber. Does that make sense? So yes, you know with those kids in YouTube and they do this, they're being very dramatic. But when they do this, they're actually thinking about the abacus in their brain. Oh, um, oh yeah. So neuro. So when we look, there is this pattern. There is a checklist. There's a framework in the abacus, right? So what we're going to do is we're going to always understand if we have enough beads. If there's enough beads, then do it. If there's not enough beads, then you have to find another way. You're communicative. You're communicative about the community. It's commutative. This is helpful. Oh yeah, yeah. There's a few people that I have a couple of people in my class. I have an online class, and she's trying to teach her son. And I showed her. So I think what I'm trying to do is I'm trying to educate the parents because a lot of the parents want to teach their children, right? And so what I'm trying to do is I'm trying to educate you guys and how to make it understanding so you could teach your children, right? Or you can join my class and I go through videos. It's up to you. Okay, so okay, after adding the 5, if we cannot, then we got to go to the 10. So we had that one question, right? The one question was 8 plus 4. 8 plus 4. What? Well, if you go on the abacus and we add the 8, and I like the abacus. The reason why is because we have restrictions, we now know where our boundaries are. It's like guiding guiding our kids, right? Like if we don't give them boundaries, we don't know what we're doing. If I give you a blank piece of paper, the sky's the limit. But in abacus, because I'm a little bit restricted, I now know how to manipulate it, right? I know now how to modify what I need it. So if I have 8, I'm restricted. I have no more beads to add the 4. So what do I do? Well, I have to ask, can I add the beads? No, I can't. So now we can go through this process. Can I add the 5? Well, can I add the 5? No, I can't because I'm already using it. So what's the next thing? The next thing is I need to plus the 10. What? Remember how to make a 10? Making a 10 is 4 plus 6 is equal to 10. We're going to modify it, right? We're going to power up and we're going to, so we can take this plus the 4. This and this is the same. And then what do? We substitute plus the 4 is equal to plus the 10 minus the 6. I just given you directions on how to move the beads. Plus the 10, 1, 0, 1, 0, and then we take away the 6, and we take away the 6. So my final answer is 12. Does that make sense? We can do it again. Because I know I talk a lot. Get it, right? So easy. I'm telling you. But because you know this, oh, here, 12. Oh my God, you dumb dog. All right, 12. Here's my tens. Here's my ones. 1, 2. Here's my tens. Oh, Pavlos. Does that make sense, Kimber? We have our ones. I'm sorry, ones and our tens. This is 12. 1, 2. So you count below the bar. You count anything that touches the bar. So this is touching the bar. We count it. If I do this, now we have 17. How do I know? Because it's the 2 beads touching it, right? I'm sorry, these are touching it. So this is 5. This will always be 5, right? 5. So if I did this, this is now 50, 67, 6, 7. This is 6, 7. Right? If I take away the 5, this is now 17. 3, 3. Yeah. So 333. That's what that would look like. 333. So let's start it over. Let's do it again, right? So we do 1. These are all ones. This is all 2s. This is all 3s. This is all 4s. And then all of this is 5. And then we do 6, right? 6, 6, 6, 6, 6, 6, 6. 7. Give me another number, Kimber, and I'll show you what it looks like. This is 8, and then this is 9. Give me another number, Kimber. Okay, so we have 1,546. 1,546. I have to make sure my beads are not touching. The reason why is because it's easy to move your beads. Make sure don't flick too hard, because what happens is now your answer becomes wrong. Junie. Yeah. Yeah, right? Super simple. Simple to use, easy to understand. But there's things, right, that you have to be careful with. You have to be gentle. Don't be doing that, because your answer's gonna be wrong. Right? Don't be like Zeus, right? We want to be gentle. And when we're looking at it, there's edges, right? Edges. What we're doing is we're just moving the beads at the edge, right? So no matter how big and burly, if I did my whole hand, right, you can still use your whole finger. So what I'm saying is you want to be gentle. Be gentle. Not You don't have to be delicate. You have to be gentle, right? This is made out of plastic. You're not going to be able to break it. Well, you could break it, but what I'm saying is you got to be gentle. Oh, okay. See you later, Nero. Right? So when we're doing it, we want to make sure we're just using the tips of our fingers, right? Yeah. How did how did I not know this? Because it's not. That's what I'm saying. It's not part of mainstream math. We have everything else. We have like stupid counting bears, but we don't have an abacus. I go to I go to a store and there's all these like counting materials, but none of them have an abacus. It's really quite upsetting. I'm telling you. I'm telling you. Okay. So, what are we doing? We're going to continue on. So, ATOC. I don't know if ATOC is still around. ATOC, did that make sense? Did we add the four? Are you still here? Did that make sense? Yeah, because that was the question. Oh, good. We can do more, right? So, what happens? We can do more. We can do more because now what we're doing is we're understanding how to make a 10, right? How do we make a 10? It seems really excellent tool. Thank you. I'm in. Thank you for. All right. So, I blame Western imperialism on abacus being obscure. Interesting. I think it's Eurocentric, right? Our math is very Eurocentric, so I'm trying to bring abacus to Eurocentric. So I do understand. I do understand, and I was trying to figure out how do I make it more accessible for, because funny, it's very popular with the blind people because they have a Kramer abacus. And a Kramer abacus is very similar to a regular abacus. It's just that it's a little bit difficult to move. So then it's not so easy to, because they can't see, right? So the beads are a little bit more difficult. And that's the only reason why I know the abacus exists, as well as it's being used in any IEP. But I believe that it should be everywhere. I don't think it should be just for the learning disabled IEP students or anybody. I think it should be, I don't think they should discriminate. All right. They should not discriminate the abacus. It is not just for, it's, which is weird to be Eurocentric because algebra, yeah, right? Algebra, yeah, right? I think it's not difficult. There's like foam behind the beads it's not behind the, maybe I don't know how they do it, but I'm not gonna, yeah, it could be that. You're right, algebra came from the middle. Our numbers, right, is Arabic. And that's the funny thing, right? That's the other thing. Our numbers are Arabic, and then it came from the middle, it came from like Mesopotamia. I don't know why there's a disconnect. Anyways, I'm gonna stop ranting. Right? The nose. I know. Anyways, okay, I'm gonna stop ranting. I'm gonna continue on because I can go off. Oh, but it's funny. I mean, that's what I'm trying to do. I'm trying to bridge the gap because the way I talk, right? I'm very westernized. I'm trying to bring in abacus because if you look at any of the abacus videos, they're saying the big friends, the small friends, the plus tens, the minus tens. No, 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 no. In mainstream math, we talk about making a 10, and making a 5. We talk about carrying and borrowing. What we're going to do right now, we do plus tens. This is what we call carrying over. So here's my question. When we carry over, see, it's different. It's just different. So here, this is what we call carrying over. We don't say it here in mainstream math, right? But in abacus world, we start from the very beginning and we slowly bring in more information. Whereas in mainstream math, you do one way and then they switch it up. And I'm like, why? So in mainstream math, you focus on the result. In mainstream math, I don't know why. I know this is 13. How do you make 13? Why do I need to learn how to make 13? I can learn how to make the 10 and that will be more than enough. I don't need to make a 13, right? It doesn't make sense to me. That's not a factor that makes sense to me. So what I'm trying to do is I'm trying to understand the add-in. In abacus world, we focus on the add-in. Hello, beep beep bloop. Thank you for the phone. What we're trying to do is we're trying to understand the add-in. So here, what we're doing, right, is 4. I want to add the 4. When I add the 4, we need to plus the 9. To plus the 9, is there enough beads? No, there's not enough beads to plus the 9. But we can. We have this concept, plus 9 plus 1 equals 10. We're going to modify it. We're going to isolate the variable. That's a very mainstream terminology. Abacus world doesn't say that. We're gonna isolate the variable. We're gonna isolate this 10, this 9. This 9 is equal to 10 minus 1, which is very similar to algebra, right? So when we do it, we're gonna substitute. We substitute the 9, we add the 10, and we take away the 1. We just did is we carried on, and we powered it up. So we plus the 9 is equal to plus the 10 minus the 1. Is it more complicated? It's a different way of thinking. We know these concepts. We know how to do it. We just don't utilize it. Right? We don't utilize it to its fullest potential. Does that make sense? I'm prone to using fours. I don't know what that means. Usually do this in my head. Oh, I see. Okay. You're doing amazing PR for Abby's. Thank you, Junie. I try my best to explain it in mainstream math terms. Bippity bloop. If that's how you do it, then that's great. I'm not judging. I'm not judging. It's just everybody does it differently. I'm just trying to educate people how to use the abacus. That's all. This is great. Oh, okay, good. Thank you. I don't know how you'd use fours. So we can count. Let's do a review. 1, 2, 3, 4. This is 4. And then the top beat is 5. Oh, I find it. Oh, good. Oh, good. Fascinating. Okay, good. So 5. This is the value of 5. 5, 6, 7, 8, 9. 9. This is 9. Well, how do I know that's 9? Because we're going to start labeling our columns. Every column is a place value. So we have our ones, our tens, our hundreds, our thousands, our 10,000. So when we look, this is 10. This is a decimal system, just like our regular numbers. Our regular numbers is a decimal system. This is not a base 5. This is not better. This is not. Well, somebody said binary, and I'm like, I don't even know how to read binary, but it's not binary. And they said binary is easier than base 10, and I'm like, okay, you do you. So, anyways, this is the 10, 11, 12, 13, 14, and then 15. 15, 16, 17, 18, 19, and then 20. How do I know this is 20? 2, 0, 2, 0. That's it. All right. Right? So we're okay? So, A talk, how are we doing? Does that make sense when we add the 10? I'm talking to A talk because he always asks questions. We okay? What's going on? How's it going? This is a little bit of review. What we're doing is we're learning how to add. We can do the same thing with subtract. What? What do you mean? Why? It's the same way. Adding 9 is like 10. Yes, exactly. Reminds me vaguely of mental maths implication of yes. But you know what? Because we add the 9, it can go everywhere, right? Now we can go everywhere. We can be more versatile. Oh, so here's a question. Here's a question. I don't know if you guys were here for that, but we can do this, right? So I have my number. My number is 1, 3, 5, 7, 8. And then what do we do? Plus the 2. Can we do it? 1, 2. Can we add the 4? Can we add the 4? I'm not changing anything here. I want to know is can I add the 4? Remember how to add the 4? This is how versatile the numbers can be. Remember we add the 4, we plus the 5 minus the 1. We plus the 5 minus the 1. Then can we add the 3? Yes, we can add the 3. And then add the 1, and then add the 1. So my final answer is yes, thank you, ATOC. Yes. So my final answer is 37,889. Yeah. Adding the 10 is yes, adding and that's what it is. When we do the tens, the plus tens, this is what we do carrying on, carrying over. So we can do bigger questions, right? So let's do a bigger question with the 9, right? So if we had if we had 99 plus 9, this is easy. I understand it's easy, but this is the concept I'm trying to teach, right? So if I show you 99, right? And what I'm trying to do, I have plus the 10 minus the 1. I need to plus the 10 minus the 1, right? Just as Junie mentioned, right? Plus the 10 minus the 1. So what we need to do, we need to plus the 10. When we add the 10, no, 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 not add the 10. We want to do is we want to minus the 1. Can we take away the 1? Can we take away the 1? Yes, we can. So we're going to take away the 1. Now we're going to do is plus the 10. 10, remember, is 1, 0. Remember how we counted 1, 0, 1. Can we add the 1? Can we add the 1? No, we can't. Cannot, because there's not enough beads to add the 1. What do? Can we use the 5? No, we can't. We cannot use the 5. What else can we do? We can, here's the 1. Plus the 1 is equal to plus the 10 minus the 9. Plus the 10 minus the 9. Plus the 10, 1, 0. 1, 0. And then minus the 9. So my final answer is 108. 108. Did that make sense, ATOC? So what did I just do? This became a two-step equation. So we did this is plus 1 is equal to plus the 10 minus the 9, right? So what did we just do? We are now Tetrising our way through. Oh, I got to get a Tetris sound bit. I'm going to get a Tetris sound bit. Do 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 and Tetris our way through. Every number that you see here can fit into every number that's in here. That's why it's beautiful because now it can be scalable. It doesn't matter what the number is. You can subtract it, you can add it. I was taught how to add abstract by counting dots on numbers. It was an experimental program. Oh, I'm sorry, Amy. Abacus is better. Yeah, the dots. I know the dots, right? 1, 2, 3, 4, 5, 6, and then you had a block, right? Or you had a stick like this. Yeah, yeah, that's too bad. I'm sorry. So let's do a review for Amy. How do we read this? 1, 2, 3, 4. 4 beads touching the horizontal bar is being counted. This is 4. So if I did this, this is all 4. 4, 4, 4, 4, 4, 4, 4, 4. So then we have 5. These are all 5s. If I do 6, notice I have 1. We did 1. This is 1. If I add 6, that's what 6 looks like, right? 5, 6, 5, 6. 5 plus 1 is 6. This is 7. 5 plus 2, right? You see 2 and then there's 5. This is 7. This is 8. 5 plus 3 is 8. and then 9. 5 plus 4 is 9. So abacus, what abacus does is it makes it into bite size. Bite size? Easy. Right? How are we doing? We're all right? So I kind of love that you have all fours and flick them clear and then bump them all fives. Yeah, but make sure you don't, because if you flick too hard, then my answer becomes wrong. So, okay, how are we doing? So that is adding 5, adding, but notice, right, we need to understand how to subtract. That was the one thing about mainstream math is the kids get confused about what subtraction is. And I'm like, why? Why are they confused? Because on the abacus, when we add it, we go to the horizontal bar. When we subtract, we move it away from the horizontal bar. So we see that we're subtracting. If this is 6, take away 1, is now, I'm sorry, 6, 7, 7 take away 1 is now 6. So when we're doing it, we're subtracting it, and it becomes very part of the system to subtract, right? We know that if we added too much, we need to subtract. We need to balance the equation. I don't know why in mainstream math we teach all adding and then we come back around and teach all subtraction, where it should be a combination, right? So when we look at it, we understand that we're going to add and subtract. So we have another number. Here's another equation. What was it? 50. This one was a good one. 54 plus, what was the number? Blah, blah, blah. It was a good one too. I think it was 9. 9. Is it here? Oh yeah. So this is another example of what they're doing in mainstream math. This is another strategy. Number bonds. I'm like, bruh, okay, bruh. I mean, it makes sense, but is this necessary? Because if we do it on the abacus, right? They broke it up into tens and ones. But see, that's what I'm saying. The difference is they're doing it on paper. On the abacus, we don't need to, right? We could see it. So if I did 34 and then want to add 23, to add the 20, to add the 3, to add the 20, how do I add 2? How do I add 2? Plus the 2 is what? Plus the 2 is plus the 5 minus the 3. Plus the 5 minus the 3. And then we want to add the 3. We want to add the 3 plus the 5 minus the 2 plus the 5 minus the 2. So my final answer is 57, right? So you could do this. That's not a problem. Or we just understand it and do it on the abacus. So what I just showed you is all we did was adding the 5, right? And it's the same concept over and over again. We're just practicing and making it, we're practicing it and it becomes part of the system, it becomes intuitive to you. It's so intuitive to my boys. I have 3 boys. It's so intuitive to my boys that they cannot teach you because they know it in their brain. I see how the abacus makes less abstract. It is make it less abstract. And that's exactly. So Amy, you had the dots and the numbers. Another one was the number bonds. And I'm like, it makes this, making it this way, it doesn't make sense to me. You know why? Even when I show you a picture of an abacus, it's still very different when I have the physical abacus. You know what I mean? Like, that's what's crazy thing, right? Our brain knows that this is a question, right? I see 4, but if I have it on my abacus, I feel the 4. I see 2. I'm going to take away the 2. I can move it. I can touch it. I can, I can see it better. I guess maybe it's because it's 3D. Is the way with the bubbles in? Is it disgraceful? It's not bubbles. They call it number bonds. It's just another way. I'm not knocking it. I'm just saying that to me it feels a little more complicated because I don't because they're trying to write it on paper, right? And so the difference is on the abacus, I could see it. I have my tens, I have my ones. So if that makes sense. I mean, it's not disgraceful. It's just they're trying to draw math. That's what they're trying to do. They're trying to draw math. And when we start doing multiplication, I was trying to find my question. When we try to do multiplication, like you can do division on the abacus. Oh, here's a question. Somebody gave me this question, right? 88 plus 2. I think it was Ethan did that. 888 plus the 2. I want to add the 2. There's not enough beads to add the 2. So what do? Plus the 2, where's me? Nope, that's not it. Plus the 2 is equal to plus the 10 minus 8. Plus the 10 minus the 8. Plus the 10 minus the 8. So my final answer is 890. It seems so many extra steps. It does. I would love to see division on the abacus, but my phone is about to go out. We can do division. Are we ready for division? Is that what we want to do? We can do multiplication. What do you want to do? We can do multiplication, and then we can do division. I like multiplication because because we do distributive property, and then we could do division. I'm just trying to find some things. Oh, okay, yeah, distributive property. So here, 29, 30. We're gonna count. We got to count 1, 2, 3. We got to know where to put our where to put our number. So we have to count 1, 2, 3. How do I know? 1, 9, 3, and 2 together makes 3. So I'm going to start at the hundreds column. So when I start the hundreds column, my next thing I'm going to do is 9 times 2. 9 times 2 is 18. I add 1, I add 8. Right? I'm not going to do 20 times 9 because we don't do that in our multiplication. What is it? Our multiplication table doesn't go up to 20. Right? Our multiplication table goes up to 12, which is still redundant. Anyways, we go to 2. 2 times 9 is equal to 18. Notice it already says it. 180. I don't need to write it. That's the difference. I don't need to write it. It does it for me on the abacus. Does that make sense? I don't need to say 20 times 90 because you're writing it. You should. But I'm not writing it. I have it on my abacus. I have 2, 18, 1, 8, 0. And then what do? Add 27. Oh, I got to do 9 times 3 is 27. 9 times 3 is 27. Plus the 2, plus the 7, plus the 2. We know how to plus the 2. How do we plus the 2? Plus the 2 is plus the 10 minus the 8. Plus the 10 minus the 8. And then we need to plus the 7. So the big thing about the abacus is you need to remember where your placement is. Because if you forget where your placement is, then you lose track. It's all about procedural. And so sometimes it's easier to write out, like this is how I keep track, right? What did I just do? What did I just do? And then I do a backtrack. But this is what I call brain gymnastics. So my final answer is 207. Right, that is multiplication. And so we do is distributive property. We're doing this in new math, right? We do distributive property in new math. What is distributive property? Distributive property is an algebraic term. So abacus introduces a lot of algebra. It's not algebra, but it's kind of like algebra, right? It's the gateway to more complex math. Abacus is the gateway to complex math. So there's so many things that I've been learning and trying to figure out how everything works. And how does abacus relate? Because abacus is math. Abacus is math. It just depends on how math it is. You made this immediately intuitive for me. Oh, good. Good. It should be. but the thing is people don't know how to read the abacus. That's why I start with read the abacus first, right? We learn how to read the abacus, and then everything will fall into a place. Everything will fall into the place. Everything will falls into place, right? Oh, good. Thank you, Amy. Thank you, Junie. Right? So what we're doing is that's why I go into adding and subtracting, because we still need to utilize this. We still need to understand how do we add, how do we subtract. Everybody always wants to go into multiplication. Everybody wants to go into division, but there's steps, right? We got to build foundations. We got to build the gap. We got to fill in the gaps. These gaps are filled with all of the stuff. So when we go through like the like all these questions, right? We have all of these questions. These are very specific questions for the abacus, right? They're 4 minus the 5. So we understand it and solidify the concept of minus the 5. And minus the 5 is, how do you take away 2? How do you take away 2 from the question minus 6? So if I have 6 and I have take away 2, see, this is what makes it funny, right? Like, it's so easy, but it's because we're old, right? If you know how to do it, then you can modify it. So if I have 6, I want to take away the 2. There's not enough beads to take away the 2. Again, right? We have minus the 5 plus the 3. And my final answer is 4. I just made it complicated, but it happens when you can scale it. So then when we start going into multiplication, it becomes scalable. When you go into division, it becomes scalable. When you get to big numbers, right? I have big numbers. Where are my big numbers? We're in big numbers. When I have big numbers like this, I just I just do it, right? As opposed to, how do I make this a friendly number? Oh, okay, let's do 1,000 or 13,580. Then I'm gonna have to remember, okay, I added the 2, and then I got to take away the 2. Oh, let me make this more friendly. You could. It's up to you. But if I put this on my abacus, I could see it, right? I know 1, 3, 5, 7, 8. Oh, 7, 8, right? I have 2. I have enough beads for 2. So if I have enough beads for 2, and then I have the 4. Remember, we add the 4. We add the 4 plus the 5 minus the 1. See, that's the foundation that we're building. These are simple questions. I know they're simple, but they're foundational. You need to know how to wax on, and then you will know how to wax off. When you know how to wax on, you will be able to wax off. What is the other one? Put on the coat, take the coat off, right? It's just like Kung Fu or Karate Kid or whatever it is, right? Put the coat on, take the coat off. Wax on, wax off. Paint the fence. You go up, you go down. You go up, you go down. It's the same thing. That's why I do the basic information. These are all my notes. I have a lot of notes. All right. Are we going to go into division? We can go into division. It's a little bit more complicated. Or we can continue on with multiplication. We can continue on with adding and subtracting the tens, right? So, but that's what it is. Okay. If you're new here, my name is Lynette. I am an abacus teacher. I'm trying to bring abacus to the mainstream. If you're looking for some books, some of the books that I have is either in my TikTok shop or it's over here. My name is Lynette. Thank you so much for joining me. Thank you so much for listening to me rant. And also, what? I also have private lessons. So you are. Thank you, Pancho. Thank you, Pancho. I appreciate that. So I've been teaching abacus for 20 years. I just now started bringing it into the internet. I know that there's a lot of people that do videos on YouTube, but they're a little bit complicated. But no, I appreciate everybody listening to me rant about mainstream math. Okay, how are we doing? We want to do some division, or we're going to continue on with some adding and subtracting? Anybody new? Anybody need a review? How are we doing? Pancho. Okay, what do we get? We can do. I have some division in me. Okay. Okay, we'll do some division. I don't know if anybody's here for that. I don't know if Ethan went to bed. All right, here's a few division questions. Divisions is kind of easy because what we do is we do the reverse. We do multiplication, but reverse. It's going to be a little bit. I'm not going to lie. It's very different to mainstream math. Junie. Oh, okay. Have a good morning. Have a good night. Have a good night. I hope you sleep well. Yeah, no, thank you for the comment. Thank you for commenting and contributing. It's a great conversation. It's a great conversation. Thank you. Okay. Night shifts. Oh, yeah. Yeah, good luck. I hope you have blackout curtains. Those are the best. Those are the best, but yeah, night shift is tough. Okay. So here, oh, did you want to look at division before you go? I don't know, it's up to you. So the first thing we're going to do, the first thing we're going to do is we're going to understand we have our divisor and our dividend. We have our divisor and our dividend. Now, these are things that we're going to have to know. And then we have a quotient. Our quotient is the answer on top, right? So because the quotient is the answer on top, one quick one. Yeah, this one should be easy. So this one, because we have a quotient on top, what we're going to do is we're going to count our digits, just as we did with multiplication, right? 1, 2, 1. So 2 take away 1 is equal to 1. So that means that my answer is going to sit over here, and I'm going to put my dividend on my abacus because that's what we do. My quotient will be 1. My dividend is these two here. So I'm going to put 75 on my abacus. The reason why is because I'm going to subtract from here. It's going to help me keep track, right? So the first thing we're going to do is understand we're going to compare our dividend and one divisor. We only compare one by one. That's all we're doing. We're only comparing one digit by one digit. We're going to compare apples to apples. So who is bigger? If my divisor is 3, my dividend is 7. My dividend is bigger. So if my dividend is bigger, I'm going to skip this column and I'm going to go over here, right? Thank you, money, for the answer. So I'm going to skip this column. I'm going to go over here. So what am I going to do? I'm going to do 3 times what is equal to 7 or less. Why? Because we don't think in division. What we're going to do is we're going to find our missing multiplication fact. So just as money mentioned, it's 2. 3 times 2 is equal to 6. So I'm going to add the 2, which is my quotient. I'm going to add the 2, and then I'm going to take away the 6. Take away 5, take away 6. So I'm left with 15. So now I have to compare again. Who is bigger? My 3 or 15? No, I'm not comparing two digits. I'm comparing one digit. So I'm only going to compare this one, right? I'm only comparing one. Now, who is bigger? Is my 3 bigger or my 1 is bigger? My 3 is bigger. So when my 3 is bigger, what am I going to do? I'm going to do 3 times something is equal to 1. That doesn't make sense. You need two digits, right? So what's the second digit? It's the 5. So 3 times what is equal to 15 or less? 3 times 5. Thank you, Bessie. Basie. So I'm going to add my 5 here, and I'm going to take away 15. Take away 1, take away 5. Skip school for no school math. So just as Money mentioned, the answer is 25. Does that make sense? So it's a little bit more involved. We're having a conversation with our questions, but as we have a conversation with our questions, we know more about the numbers. Does that make sense? Funny, I actually have a few kids that introduces me. I'm still gonna watch those since I have state testing. You know, funny, I have a few kids watching me and they show me to their teachers. And I'm like, you should be in school. You don't need to. Hilarious. And they're like, no, my teacher said it's okay because you're teaching math. I'm like, oh, okay. Junie, did that make sense? Right? That's what I'm saying, right? That's what I'm saying. So much faster than visualizing long. Yes, and funny, abacus does long division. It did, right? Oh, thank you so much, Junie. Okay, have a good night. Have a good night. Have a good night. Thank you for joining. Thank you for the conversation. Hey, Rodrigo. Thank you for the rose and the rosa, right? So what we're doing is we're having conversation with our numbers, but we're sticking with understanding our multiplication fact. I'm not going in and saying, okay, 3 times what is equal to 75, right? I'm not saying, okay, 3, I know 3 times, I don't know, 25, I'm sorry, 3 times, I don't know, 3 times 10 is equal to 30. I need to go to 75. I'm not going to say 3 times 2 is equal to 60, right? What else do they do? Then, okay, we're very close. Then we know, okay, 3 times 22 is 66. Then what do? They do, oh, you know what? We got to do a few more. 3 times 23 is 69. Oh, no, we got to do one more. We got to do 3 times 24 is 72. No, no, no. We got to do 75. We're not. Oh, 3 times 25 is equal to 75. Oh, ding, ding. We're not doing this, right? We don't need to do this. We just need to have a conversation with our number. Hey, zone of friendship? Yes, you're right. I don't know if you can see it. It's right there. Tim Cheese, thank you so much. The question is 27 times 30. All right. Let's do it. Let's do it. This is brilliant. I don't need to do this. I'm not doing this. That's too much work. This is way better, right? Because we're sticking with the information that we understand. All right. So, okay, I want to keep this, but I need to not. All right. I'm going to keep it. Are you saying this is better doing division than the algorithms? It's whatever is easy for you. You do you, boo. If you want to, if you want to, it is up to you. It's up to you if you want to learn something different. It's okay. I mean, we all learn differently. I'm not here to judge. Okay, so we have 207, no, sorry, 27 times that by 30. So when we look, we're going to understand. Thank you, Tim Cheese. What we're going to do is we're going to understand how many digits we have. We have 1, 2, 3, 4. 1, 2, 3, 4. So we're at the thousands. When we at the thousands, right? What we're going to do is we're going to do 3 times 2. We understand 3 times 2 is equal to 6. 6, if we make this into a double digit, right, it'd be 06, like we do time. 1 o'clock, 1:06, or 12:06, right? What we're doing is we're, doing this. So we're going to do 06. I'm going to add the 6 here. So then my next question is 7 times 3. 7 times 3 is equal to 21. I add 20, and then I add the 1. And what's my final answer? Just as Zone of Friendship said, 810. 810. Tim Cheese, does that make sense? So when we look, we're not doing 20 times 30. We don't need to do that. We don't need to say 600, right? The reason why is because the abacus does it for me. It's already here, right? 6 is already on the 600. And then what are we going to do? We do 7 times 30 is equal to 210, right? So instead of doing 210 I just go 20, I go 1. So in our multiplication table, we don't go to 200. we don't go to 20s and 30s, right? So what we're doing is we're understanding that we take our multiplication table and we solidify it. We solidify our information. We do 7 times 3 is equal to 21. We can do another one, right? We do 28 times that by 61, right? Same thing. 1, 2, 3, 4. 1, 2, 3, 4. So this is called distributive property. Property. This is the very beginnings of algebra. Because this is the very beginnings of algebra, we're doing distributive property. In mainstream math, they're calling this new math. But it's not. It's actually old math. 6 times 2 is equal to 12. Add 1, add 2. Then we do this. 6 times 8 is 48. Add 4 plus the 5 minus the 1, add the 8. And then what do? We're done with this. All right. What's the next one? 1 times 2 is 2. Is equal to 2. 2. Add 2 here. Plus the 10 minus the 8. And then 8 times 1 is 8. 8 is a single digit. I go back 1 column. I add my 8. So then what do? My final answer is 1,708. How are we doing? We can do more multiplication. Can you explain the placement value operation? Meaning 6 times and then okay, cool. You're not even explaining how to read the machine. So Pancho, when we do 6 times 2, right? We're not doing 60 times 20, right? If we do 60 times 20, it's 1,200. But if you notice, I do 12. 6 times 2 is 12, plus the 1 plus the 2. Why isn't the 4? Because 1, 2, 3, 4. Did that make sense? That's why it's in the 4th column. Then, because I'm over here, when I do 6 times 8, right? 6 times 8 is 48. So what we're doing is we're just cascading it. Just like how we do in math, right? 28, 61. But we cascade it, right? So it's 28 and then 0, and then this is what? 8, 4, 12, 6. Does that make sense? So just like what we do here, but in mainstream math, we do it the ones first. But in abacus world, we don't. We start from the outside in. So I mean, you could do it the other way. I mean, it's up to you. But that's why we do. So we have to cascade it. Does that make sense? $48. Somebody said. Ethan said that it was my hieroglyphics. Hieroglyphics. Yeah. Another way I saw it was 60 times. Yes, exactly. So yeah, it would be 60 times 8. So that's if you were to write it out. It'd be 60 times that by 8, which would equal to 480. You're absolutely right. But that's if you were writing it out, right? But in abacus world, we don't need to write it out. We would just add it. 480. 480. 480. I don't know if that's right. Should be. right? Yeah, that's right. Yeah. But see, that's the difference between mainstream math and abacus, right? I don't need to do 480 because my abacus does it for me. I just keep moving it over, if that makes sense. Yep. Yup. Yep. 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 What are we? Oh yeah, got it. Okay. Okay. So when we're looking at it, I don't know if L Eddie is still here, and I don't know if Zone of Friendship is still here. Tim Cheese, I don't know if you're still here. Is it better than the algorithm? I don't have to memorize algorithms, right? What I do is I memorize procedures, because now they talk about being procedural fluent. And then what do? I memorize my formulas. These are the formulas I need to memorize. And then I need to know my times tables. If I need to know my times table, then I don't need to worry about algorithms. This will be the gateway to algebra, right? Algebra, we memorize formulas. I looked in this and then unlocked. I forgot. Yeah, you're welcome. Um. Okay. How are we doing, Pancho? Do we want to do another multiplication? Hey, Jalen, can you show us 18 times 37? Yeah, I think I understand. Oh, okay, yeah. Okay, so let's take it slow. Boop, boop, boop. Okay, 18 times that by 307. Let me know if I go too fast, because I know I talk fast. So what we're going to do is, and one more division before ending this part. Okay, go. We'll do one more division, and then we'll do one more multiplication, because that's my first yawn. All right, we're going to count 1, 2, 3, 4. When we look, 1, 2, 3, 4. The reason why is because I'm starting here on my ones place, right? Thank you, Buns. Thank you for the rose. Okay, so what's going to happen? We're going to do, it's called distributive property. Distributive property. I don't know if I spelled it right. Whatever. Property. Okay. The first thing we're going to do is we're going to understand we're going to break it up, right? 3 times 1 is equal to 3. Now, if we made this into a double digit, it would look like 0, 3, right? That's not too far. That's not too difficult because we talk about two-digit numbers, two-digit math, two-digit date, right? Two-digit time. 0, 3. So I'm going to add the 3. What's our next one? So in here, Pancho, in here, it would be, it would look like this, right? 30 times 10 is equal to 300. But if you notice, I already have 300 on my abacus. I don't need to write it out. I trust my abacus. You got to trust your abacus, right? Okay, what's next? Yeah. If it's a single digit, if it's a single digit, you go back one column. That's one way to remember. Or it makes it, or make a single digit into a double digit. So then we have 3 times 8 is equal to 24. So in mainstream math, we do 30 times 8 is equal to 240, right? But here, I go 240, 2. I want to add the 2. Jalen, I want to add the 2. How do I add the 2? Can I do it? How do I add the 2? I want to plus the 2. How do I plus the 2? Yes, thank you. plus the 2 is plus the 5. So when we talk about it, we want to say it in numbers. Plus the 5 minus the 3. Plus the 5 minus the 3. That was the 2. And then we need to add the 4. Then we need to add the 4. When we add the 4, because what? It's 24. 24. We only need to do 2 columns at a time. So we're done with our 3. We can recount, or we just take away 1. It's up to you. 1, 2, 3. 1, 2, 3. Right? So we could do 7 times 1 is equal to 7. Or we can do 7 times 10 is equal to 70. You could do that. 7 is a single digit. I'm going to make it 07. So that means 0, 7, plus the 7. Oh, I think I definitely get it now. Yeah, right? So plus the 7. How do I plus the 7? Plus the 7 is what? Plus the 7 is plus the 10 minus 3. Plus the 10, 1, 0, 1, 0. Plus the 10 minus the 3. Take away the 3. And then what do I do? 7 times 8 is, oh my God, what's 7 times 8? Is it 56? Right? 56? Good. Add the 5, add the 6. Ha! 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 666. I'm not sure if anybody's religious, but that's the answer. Right? Right. 666 is the answer. But that's a good question. Why? Because we did a few things, right? Again, these are the things that we need to know already ahead of time, right? And so when we look, these are the few things. This is like how to make a 5 and this is how to make a 10. And what we're doing is we're stacking it. So again, if you notice, I have the mainstream math is this, but we don't need to do this, right? Actually, right? Does that make sense? So then what we're doing is you can add it all together, or you can use the abacus to help you. It's up to you. Cool. Okay, last one. We're going to do division. Okay, division. I want to find. Okay. All right. Jalen, that's great. That's great. So it makes sense, right? I'm happy. I'm happy it makes sense. Good. And it makes it easier, right? I find it's easier, right? We don't need to worry about all. Where am I going? We don't need to worry about. Oh, excuse me. We don't need to worry about too many digits. Let's see if we can do this. Let's do that one. The first thing we're going to do is we're going to understand where we're going to put our number. Maybe I should do that. Where are we going to put our number? Oh, excuse me. Okay. We need to remember our dividend and our divisor. Right? So the reason why is because we need to know where to put our number. We have to count just like we did for multiplication. Yeah, I wish I learned this in primary school too. It would have been a lot easier. But hopefully you can live vicariously through your children and you will teach your children. I know I teach my children, but they take it for granted. Whatever. They don't know what's better. But I know that this is a better route because we don't have to worry about all the extraneous stuff. There's a lot of strategies to add and subtract, to do multiplication and so forth. But in abacus, we don't need to do that many strategies. We just need to know the fundamentals. So again, what we're going to do is we're going to figure out our place value. The reason why is because then we know where to put our number. We don't want to have a bigger number than it already is, right? Because if we had the answer 438, then we know that that's the wrong answer. So we have two digits for dividend and one divisor. 2 take away 1, 2 take away 1 is equal to 1. So my answer is going to be here. This is where my quotient will be. It's a moving number, right? There's my quotient and there's my dividend. My quotient will be here, 1. My dividend is going to be here, 68. Now what do is I got to compare. I compare my apples to apples. I only compare 6 and 4. So when I write my chart, divisor and dividend, my divisor is 4. My dividend is 6. Who is bigger? My 6 is bigger. Because my 6 is bigger, I'm going to skip this column and I'm going to go over here. That's one of the rules. I'm just going to skip my column and go over here. So my question is 4 times what is equal to 6 or less? Why? Because I just need to know what goes into 6. We don't really think about division. We think about the opposite of division is multiplication. We find the missing factor. So 4 times 1 is equal to 4. So I add 1 on my abacus. That's my quotient. And I take away 4 here. To take away the 4 from 6, we know minus the 5 plus the 1. So now I have a new dividend. Because I have a new dividend, I'm going to do a comparison again. I'm not going to compare 28. I'm going to compare one digit with one digit. My 4 and this one digit, 2. Who is bigger? My 4 is now bigger. When I rewrite my number, when I rewrite it, when I set up my question, it's going to be 4 times what is equal to 2. That's never going to happen. We need the next number. We need it to be 2 digits. So I'm going to add this second column, 8. Now my question is complete. 4 times what is equal to 28 or less? 4 times 7? Put my 7 here, take away 20, take away 8. So my final answer is 17. Right? Which is very different than, well, 4 times 15 is equal to 30, right? Is that right? No, 60. That's right. Thank you. Right? So then we would do what? 4 times 6 is what? 64, right? And then we do 4 times 7 is 68. I mean, we teach this way for long division. You could, or you break it up into smaller chunks. So that's the difference. Save me this one. Nice. Okay. Can you do division problem with a decimal? Ha! Pancho and Ethan are talking together. Oh, excuse me. I want to see decimals. We could do it right now. You want to do it now? We can do it now. Because that's easy. Easy! That's a quick one. This is a quick one. 2 divided by 25. I can't promise you to get to division tonight. Okay, let's do it. Let's do it. I want to see decimals. Yeah. So let me. Okay. So here we are, divisor and our quotient, right? So let me know where are we going to put our number? Where are we going to put our answer? Where are we going to put our answer? Do we remember how to find it? We have our divisor and our dividend. Pancho, you still there? Ethan, you still there? Hmm. Hey, Tracy. Welcome back. Hey, okay, good. Dividend and our divisor, right? So what we're going to do is we're going to figure out where to put our number. So we have 2. Here, just my second division. I'm a bit unsure. This is my second division problem, so I'm a bit unsure. Lost. Okay. First question is where am I going to put my answer? Where am I going to put my answer? Right? We know 2 digit is 2 dividend, right? 2 digits minus 1 is equal to 1. So I'm going to start here. My quotient will be here. My dividend will be here. I add 2. I add 5. Now we're going to do a comparison. 2 or 2, they're the same. So if they're the same, we got to go to the next one. 5, and we pretend that there's a 0. Yep, 0 and 5. Who is bigger? Do you put the dividend in the decimal places? Yes. I put the dividend right side to the quotient. No. It's not the decimal places. It's the right side. Because the dividend, that's a good question. The dividend helps me track my quotient. So my quotient can be up here. Then I would have to move all of my dividends over here. Does that make sense, Ethan? So if I start from here, then my dividend will be here. So it's the left side, it's the right side to my quotient. That is how I know where I put my dividend. So my dividend is bigger. Now we're going to have our conversation. If our dividend is bigger, okay, good. So my dividend's bigger. I go back to my question. 2 times what is equal to 2 or less? Because I'm here, because I skipped. This is what tells me that I'm skipping my number, right? I have 1. Because what? 2 times 1 is equal to 2. I take away the 2. I'm done. Now what am I going to do? Now I need to compare again. My 2 and my 5. 2 and 5. Who is bigger? My 5 is bigger. So again, I'm going to skip. I'm going to skip this column. See how I use my columns to help me? Oh, I don't have enough. Let me regroup. There. So 1, 0, 5. Yeah, there we go. Why? Because we have to go to decimals. The reason why is I needed extra numbers. So 5 is bigger. So my question is 2 times what is equal to 5 or less? 2 times 2, right? 2 times 2 is equal to 4. So I had 2 here. and I take away 4, you skip from dividend on the abacus. Yes, because my dividend is bigger. Because my dividend is bigger, I need to skip it. So now I have to take away 4. We know how to take away 4. Minus 4 is equal to minus the 5 plus 1. Minus the 5 plus the 1. Now what do we do? Thank you, dog. Now what do? We have to compare again. 2, right, is our dividend, or is our divisor. 1 is our dividend. Who is bigger? Our 2 is bigger. So when we set up our question, what does it look like? 2 times what is equal to 1? No. We need to pretend that there's a 0. We need to remember that there's a 0 as a place value. So what we're going to do is we're going to make this 2 digits. Because my 2 is bigger, my divisor is bigger, I need to have 2 digits. So 2 times what is equal to 10 or less? 2 times 5 is equal to 10. Take away 1, take away 0. So my final answer is 12.5. 12.5. Can you do that again on the 12? Okay. So my dividend, my divisor, why not 1? Because 2 times what cannot equal to 1. My multiplication table doesn't tell me 2 times something is equal to 1. That's why. You have to have it as a 10. You have to make it a 2-digit number. You know what I mean? Does that make sense? You need to make it a 2-digit number because 2 times what doesn't make sense to 1. So you add a 0. Yes, you always add a 0 because that's a place value, right? If there's no more, then you add a 0. Yeah. If there's no more, you just add zeros. AI TikTok, you're back. Does that make sense? Yeah. Okay, good. Good. Pancho, you all right? Yeah. It makes it more manageable. How does the abacus represent the answer? 1, 2.5. Tens, ones, decimal, 5. Ones, tens, right? Every column is a place value. Yeah, no, you're welcome. The decimal sits between the ones and the tens. It doesn't sit on a column. So then we have our decimals. These are all our decimals. About the, yep. So when you look, I have a ones indicator right here. This is my label. This label is my ones, just like a Pokemon. Right? You could choose this one, but because we were doing division, I needed more room to help me with my divisor. Dividend. I'm sorry, Tracy. You're gonna have to catch me in my next live. I'm really spent. I've been on for 2 hours. I need to continue on. Yeah. Um. Yeah. Thanks. I will be back on tonight, 8 p.m. Central. No, Pacific. 8 p.m. Pacific. Oh, excuse me. I'll be on again, 8 p.m. Pacific. I feel like I feel like you're gonna get some sleep after. Yes. You know, funny, I take naps. After my live, I take naps because I'm just so spent. It's because it's so much energy, and I get so excited when I talk about abacus and stuff. Yeah, but when I notice when I start yawning and make mistakes, then I know I need to end the live. But I do appreciate everybody joining. I do appreciate everybody joining, even in the eve. Yes, yes. I take it in. I take it in the morning, and and then I go to bed. I take a nap, like a 10-20 minute nap after my first. Excuse me. Yeah. See, when I start yawning, I know that it's time for me to head out. So, but yeah, I wanted to get to the division because we don't get to division very often. Um, and so there's not a lot of people. It's just easier to get to division. When there's a lot more people, we get stuck on adding and subtracting. So yeah, it's always about the people, right? If there's less people, then we can go through it faster. If there's more people, then we go a lot slower. But yeah, that's the plan. 8 a.m., 8 p.m. All right. Thank you guys for joining. Thank you guys for joining. Uh, if there's any other things, I look forward to more division here. There's too much of it in there's too much of it in our society. Funny, we don't the funny thing is we don't think of division this way. We think of division this way, right? How he times everything. It was like that's a lot. So yeah. Thank you so much, Ethan. I will see you in my next live. Thank you so much. All right. If everybody else is okay, I'm going to end the live. Thank you guys. Have a good day. Have a good morning. Have a good night. And I'll see you in my next live. I'm planning to come back on at 8 p.m. Pacific Standard Time. Cool. Thank you guys for joining. It was a great conversation. Thank you guys. Yeah. Pancho. I still laugh at your at that one multiplication question and lost everybody. All right. Thank you guys. Thank you. Thank you. Have a good day. Have a good night. Have a good morning. Bye, everybody.